Imagine looking up at the sky, seeing the countless stars and countless possibilities. You must wonder, are we alone in the universe? In 1961, Dr. Frank Drake created an equation known as the Drake equation. It helps to estimate the number of sentient civilizations in the galaxy that can communicate with us.
This guy, whose name is Dr. Frank Donald Drake, created this Drake equation, which look like this: n equals to r times fp times ne times l fl times fi times fc times l. Each letter in this equation represents something important, and don't worry, it looks complicated, but we'll break it down. N represents the number of civilizations that could communicate with us, and R represents the number of new stars formed per year in our galaxy. FP represents the fraction of stars that have planets. NE represents the number of planets per star that could support life. FL represents the fraction of those planets where life actually appears, and Fi represents the fraction of those planets where life becomes intelligent. Fc represents the fraction of intelligent life that develops technology to send signals. And at last, L represents the average number of years these civilizations survive and continue sending signals. Now I will break it down this equation into steps. Step 1: Star formation rate. To start, we need to know how often new stars form in the Milky Way. Right now, scientists estimate there are 1 to 3 stars form per year in our galaxy. Why does this matter? Because stars are where planets form, and planets are where life begins. In the past, we had no idea how many new stars were forming, but thanks to modern telescopes like Hubble and James Webb, we now have a much clearer picture. These are around 100 to 400 billion stars in the Milky Way. That's a huge number, right? But only a fraction of those stars are forming right now. Some galaxies create thousands of stars per year, while others barely form any. If we were in a galaxy where star formation had already slowed down, life might not have had has as many chances to evolve. So, based on estimates, we assume about two new stars form every year in our galaxy. Step 2: How many stars have planets? The next question is: do most stars even have planets? A few decades ago, we didn't know if planets were common, but then we started discovering exoplanets, planets outside our solar system. The Kepler Space Telescope was a game changer. It looked at thousands of stars and found that most stars have planets. Studies suggest that nearly every star has at least one planet. Some have rocky planets like Earth, while others have gas giants like Jupiter. For our equation, we assume every star forms with planets, meaning Fp is approximately equal to 1.0. Step 3: How many planets can support life? Not every planet can support life. Some are too close to their star and get burned up, others are too far and freeze. Scientists look for planets in the habitable zone, the distance from a star where liquid water can exist. Why is water important? Because every life form on Earth needs it. Estimates suggest that 20 to 50% of stars have at least one planet in this zone. That's millions of potentially habitable planets in our galaxy. A great example is Kepler 452b, a planet that orbits in the habitable zone of a star similar to our sun. Could it have life? We don't know it, but it's one of the best candidates. For our equation, we assume n is approximately equal to 0.2 to 0.5. Step 4: How many planets actually develop life? Even if a planet is the habitable zone, does life actually start? On Earth, life began about 3.5 billion years ago, but we don't know how common this is elsewhere. One theory is that life could start easily on any planet with the right conditions. Another theory is that Earth was incredibly lucky and the life is extremely rare. Scientists have found amino acids, the building blocks of life, on asteroids and comets. That means the raw materials for life are everywhere. For now, let's assume that if conditions are right, life forms easily, so we take FL is approximately equal to 1.0. Step 5: How many planets develop intelligent life? So life starts, but how often does it evolve into something intelligent? Earth had life for billions of years before intelligent species appeared. Dinosaurs ruled for 165 million years, but they never built cities or spaceships. Is intelligence rare or just a matter of time? One idea is that evolution favors intelligence, meaning once life starts, it will eventually lead to intelligent species. Another idea is that intelligence is just one of many possibilities. Maybe other planets are filled with giant plants or super smart dolphins that never built technology. Since we only have one example ourselves, this is a tough one to estimate. Some scientists guess Fi is approximately equal to 0.01 to zero point 0.1, meaning only 1% to 10% of planets with life might evolve intelligence. Step 6. How many civilizations try to communicate? Even if intelligent life exists, does it actually send out signals? Humans have been using radio waves for only 100 years, a tiny fraction of Earth's history. Maybe alien civilizations use a completely different method to communicate, or maybe they don't want to be found. There is also the great filter theory, the idea that most civilizations destroy themselves before they reach advanced technology. Wars, resource depletion, or even AI gone wrong could explain why we don't hear from aliens. So we estimate FC is approximately equal to zero point 0.1 to zero point 0.2, meaning only a fraction of intelligent civilizations try to communicate. Step 7. This is the last step. How long do civilizations last? Civilizations don't last forever. The Roman Empire lasted 1000 years, but our modern world has only had advanced technology for about a century. If civilizations last millions of years, then there should be many out there. But if they only last a few hundred years, they might disappear before we ever hear from them. Let's assume and every civilization lasts 10,000 years before collapsing or evolving into something else. So we said L is approximately equal to 10,000 years. Now let's do a final calculation and conclusion. Let's put in reasonable estimates. N equals to 2 times 1.0 times 0.2 times 1.0 times 0.01 times zero point 0.1 times 10,000 years, which is the output value is n equals to 4. That means, based on this equation, there could be 4 civilizations in our galaxy trying to communicate. But since many factors are unknown, the real number could be 0 or millions. So the question remains, are we alone or is the universe full of life? If there are 4 civilizations, why haven't we heard from them? One possibility is distance. The Milky Way is vast, 1 lakh light years across. Even if an alien civilization sent a signal, it could take thousands of years to reach us. And what if they are not using radio waves? Maybe they communicate through quantum entanglement or some method we can't even imagine it. There is also the idea of self destruction. If advanced civilizations only survive a few centuries before they collapse, there could have been many before us, rising and falling before we ever had the chance to detect them. Or maybe they are out there, but they are just watching. Some scientists believe in the zoo hypothesis, the idea that aliens are deliberately avoiding contact, letting us develop naturally like animals in a nature reserve. Then there is another possibility. We might be the first. Maybe life is rare and intelligent civilizations are just starting to emerge. In that case, the future of space exploration could be up to us.
Final question. So, are we alone? The Drake equation does not give us the final answer, but it helps us estimate. If alien life is common, we should be detecting signals. If it's rare, maybe we are really alone. But space is huge. Maybe we just haven't been listening enough. Or maybe aliens are listening to us right now. What do you think? Are we alone or are there many civilizations out there? Let me know your thoughts in the comment section.